Good day everyone. I am Johanna Amor Embalbutin reporting for today. I will tackle about the solutions of routine problems and solution of non-routine problems. The learning outcomes of this topic are you will know about the meaning of the routine problems and the non-routine problems. And next, the differences of routine problems and non-routine problems. And last, you will know how to solve the routine problems and non-routine problems. We can categorize problem solving into two types. It is the routine and non-routine problems. The purposes and the strategies used for problem solving are different for each type. What is routine problems? Routine problem solving involves using at least one of the four arithmetic operations to solve problems that are practical in nature. It stresses the use of algorithms to solve the problem. For students to be successful in solving routine problems, they first need to understand the meaning of an arithmetic operation. As to which operation to use to solve the problem is the skill that has to be learned next. Armed with these two skills and a good grasp of the problem situation makes solving routine problems much easier. Using the steps or phases in problem solving will be of great help too. One strength of this type of problems is that it can be assessed easily with paper and pencils tests, typically focusing on the algorithms being used. However, by its nature, routine problems are not that good in fostering higher order thinking skills and creativity, since they can simply be solved with the use of algorithms. Further, routine problems do not promote divergent thinking as each problem usually leads to one correct solution. Examples of routine problems. Example 1. Kayla jogs 5 times around a rectangular plaza every morning. If the length of the plaza is 58 meter and its width is 34 meter, then what is the distance Kayla jogs every morning? Example 2. Fletcher Hillgrim and Rain sold 60 kilograms of mangoes one weekend. If each kilogram cost 90 pesos and they divide their income in the ratio 3:4:5, then how much did each get? These two examples are classified routine problems because they can be simply solved by applying the formula or by a defined and predictable step-by-step procedure. For instance, in example 1, the problem can be solved by finding the perimeter of the plaza and by multiplying it by 5. Distance jog is equal to 5 times perimeter of the plaza. It is multiplied by 5 because, as you can read in the problem in example 1, Kayla jogs 5 times around a rectangular plaza every morning. So, I just explained where the 5 came from. If probably you would wonder where did I get it. Next step is 5 times the formula of the perimeter of rectangular plaza, which is 2L plus 2W. That L means length and the W means width. Next is equal to 5 open parenthesis 2 times 58, which 58 is the length in the given problem, plus 2 times 34 and 34 is the width, close parenthesis, equal to 5 open parenthesis 116 plus 68, close parenthesis, equal to 5 times 184 is equal to 920. Therefore, Kayla jogs a distance of 920 meter every morning. Let's proceed to example 2. To solve problem number 2,
a simple multiplication and application of knowledge in partitive proportion will do. That is, total cost of mangoes is equal to 60 kilogram times 90 pesos is equal to 5,400. This amount will be shared by the three boys in the ratio 3:4:5. It means that Fletcher gets 3/12 of 5,400 or 1,350 pesos. Helgrim gets 4/12 of 5,400 or 1,800 pesos. And Rin gets 5/12 of 5,400 or 2,250 pesos. If you would wonder where did I get the denominator 12, I just simply add the ratio 3 and 4 and 5 in getting it. To check if the answer is correct, add the shares of the three boys and see if the total is 5,400. Then, the ratio of 1,350 to 1,800 to 2,250 in simplest form must be 3:4:5.
What is non-routine problems? A non-routine or non-traditional problem is a problem in mathematics where one does not really have an idea how to go about in solving the given problem. The problem may be solved in many different ways or strategies, and others may have more than one answer or solution. Non-routine problem solving, according to Gelfeder and Del Regalo 1999, stresses the use of heuristics and often requires little to no use of algorithms. The use of heuristics in this case does not guarantee a solution to a problem but provides a more highly probable method for solving the problems. Based on the definitions stated above, non-routine problem can be an excellent tool in developing and enhancing the mathematical creativity of students. Since the solution or solutions is or are not yet readily within reach of the problem solver upon initial inspection of the problem, then the student has to examine, probe, and analyze the problem situation and explore possible strategies to start the problem-solving process. Also, because a particular problem may have multiple solutions, then the student would have the tendency to exercise divergent thinking to come up with a solution.
Examples of non-routine problems. Example 1. Rex bought a box of chocolates. He gave half of his chocolates to Ian. From the remaining ones, he gave 15 pieces to Pinky and another 25 pieces to Chris May, and has 18 chocolates left. How many chocolates did he buy? Example 2. A store owner arranged shoe boxes into rows such as follows. She places one box in the top row, two boxes in the second row, four boxes in the third row, 8 boxes in the fourth row, and so on. If the number of boxes in each row increases in the same way, how many boxes does she place in the 10th row? These two problems are classic examples of non-routine problems. Younger children, and may be those who are neophyte problem solvers, may resort to guess and check to solve example 1. There's nothing wrong with that. In fact, finding the solution using guess and check proves that you really understand the problem. You even enhance your calculation and estimation skills as these are actively in the process. However, the problem can be solved with fewer steps by using working backward strategy. Now, I will show you the process on how to guess and check the example 1 of non-routine problems. We already know he gave half of his chocolates to Ian, so we can conclude that the remaining ones is the another half. But the remaining ones, which is the another half, Rex dividedly give it by giving 15 pieces to Pinky and another 25 pieces to Chris May. And it says another 25 pieces, which means isa pang 25. So, we can guess that the other 25 pieces was already given to a certain person and has 18 chocolates left. By guessing the another half of the chocolates, we just simply add the pieces of remaining ones, which is the 15, 25, 25, and 18. And it is equal to 83. So we can say that 83 pieces of chocolate was given to Ian. And finally, by getting the answer on the question in example 1, we just simply add the half of his chocolates given to Ian, which is 83, and the remaining ones, which is we totally guess the another half, that 83 also. And its total amount is 166. So we can say that the pieces of chocolates he buy is 163 pieces. On the other hand, example 2 may be solved by first using a drawing. Then from that, a pattern may be developed and used to arrive at the solution. First is we draw the one box in top row, then 2 boxes in the second row, 4 boxes in the third row, 8 boxes in the fourth row. From that, we find the pattern that are developing. Here's the pattern so far: 1, 2, 4, and 8. And what's come next to this pattern? The real question is, what really happening in this pattern? As the number of each row increases, the store owner multiply 2 shoe boxes to the row than the row before. The pattern is multiplying by 2's. So, 1 times 2 is equals to 2, 2 times 2 is equals to 4, and 4 times 2 is equals to 8. So, as we can see that the pattern is correct, we can continue it and finally know how many boxes does she place in the 10th row. So, 8 times 2 is equal to 16 boxes, and it is in the 5th row. 16 times 2 is 32 shoe boxes for the 6th row. 32 times 2 is 64 shoe boxes for the 7th row. 64 times 2 is 128 shoe boxes for the 8th row. 128 times 2 is 256 shoe boxes for the 9th row. And last is 256 times 2 is 512 shoe boxes for the 10th row. Therefore, the store owner placed a 512 shoe boxes in the 10th row.